Hello, everyone. Good afternoon and good evening. You're also invited to welcome to session 7A. Myself, Deepika Jain, and this session will be moderated by me. On behalf of Global Knowledge Research Foundation and the entire team of ICICT 2023, I welcome you here. It is my great pleasure to welcome you to the International Congress on Information and Communication Technology, ICICT 2023, London, United Kingdom. The 8th edition of this conference is being held in a hybrid mode. The physical conference was held at London, UK on 20th and 21st February, and the virtual event is being held on 22nd and 23rd February. I hope you will enjoy this informative session. And in this session, we have 6 presenters. The presenters would be getting 12 minutes for their presentation and 2 to 3 minutes for their question and answers. On 10 minutes, I will be raising a gentle reminder. Please take care of the time frame as we do not want any delay in the further sessions. Yeah. And there is other request for the participant to stay in touch with the session till the end. And if you have any queries, you can message me directly. And just before we get started, I would like to introduce to our session chairs. Just a minute. Kirit Modi. He currently working as a professor and head at CEIT department, IQAC coordinator at Sankarchand Patel College of Engineering and Dean at Faculty of Computer Science. He has more than 20 years of teaching experience. He has published more than 25 research papers and has served as a member of editorial board and program of international conferences and journals next in Web of Science. He has received the award for Best Professor in IT at World Education Congress Global Awards in 2013 and President Award for Staff Excellence in the category of the Research for the year of 2018 at Ganpat University. I welcome you, sir. And we also have another session chair with us, that is Alan Maurice. Just a minute. He has finished his studies at University of Polytechnia, Timisoara from Romania. And he is a senior software engineer in web development in the corporate world and also teaching at the Department of Computer and Information Technology from the Faculty of Automation and Computers from UPT. That is University Polytechnia, Timisoara. I welcome you, sir. Sir, would you like to say anything about yourself?
Thank you. I would like to make a short opening for the participants. Distinguished guests, honorable speakers, esteemed colleagues, and dear participants. It is my pleasure and honor to welcome you all to the International Congress on Information and Communication Technology. On behalf of the organizing committee, I extend a warm welcome to all the participants from around the world who have gathered here to share their knowledge and expertise in the field of ICT. Today, we have brought together a group of leading researchers, practitioners, educators, and students to exchange their ideas, experience, and insights on the latest developments, challenges, and trends in the field of ICT. The Congress is a platform for researchers, educators, and industry professionals to come together to share their expertise, research, and experiences. In today's interconnected world, the importance of ICT cannot be overstated. ICT has revolutionized the way we live, work, and interact with each other. It has created new opportunities, enabled innovation, and transformed industries. As we gather here, we recognize the critical role of ICT plays in the shaping of our world, and we acknowledge the need to stay at the forefront of this dynamic and rapidly evolving field. The Congress offers a unique opportunity to share the latest research findings, learn about new techniques, and interact with colleagues from different parts of the world. We hope that this Congress will be a stimulating and engaging forum for discussion, debate, and exchange of ideas. We also hope that the Congress will foster collaboration and partnerships and will contribute in advancing the field of ICT. Finally, I would like to express my sincere appreciation to the organizing committee, the speakers, the reviewers, and all those who have worked hard to make this Congress a reality. I wish you all a productive and enjoyable session. Thank you.
Thank you so much. Thank you, sir. Kirit Modi, sir, would you like to say something?
Yeah, so thank you, Deepika, and good afternoon, good evening to all the participants. And I think I also welcome to the Aline as a session chair. And this is really nice the arrangement which I have seen today. And I welcome to all in this the International Congress on Information and Communication Technology. And I wish that in this session we all actually learn, and we all actually will be familiar with some new research concepts and ideas which are, I think, will be shared by our eminence, the presenters. So with this, I'm thankful for giving me the opportunity to join the session chair. And with this, let's start our session. Yeah, please.
Thank you. Thank you, sir. So we'll start with our session. We have our first presenter, Daisuke. Are you here?
Yes, I'm here.
Thank you. So you can start sharing your screen.
Yeah. Can you see this right?
Yes, I can see your
Yeah.
screen and your audio is also
Okay.
clear. You can start.
Hello, everyone. My name is Daisuke Imori. I belong to the Graduate School of Science and Technology, Gunma University. Thank you for your time
A
today.
little bit louder, please.
The title of my presentation is 12-bit 1 picosecond resolution time-to-digital converter for LSI test system. This is a joint project of Gunma University and ROM Semiconductor Limited, Japan. And Daisuke Imori will give the presentation. The outline of my talk is as follows. First of all, let me explain the research objective. The feature of the proposed high-resolution TDC includes low cost and fine-time resolution. TDC stands for time-to-digital converter, a circuit and that measures the time difference between two signals to obtain a digital output. Miniaturization has also made it possible to achieve 1 picosecond solution. However, to obtain high resolution, it is necessary to use a two-stage delay line, which increases the construction cost. Also, the time resolution becomes smaller as the delay line increased. In contrast, the proposed method can be developed at low cost because it is only used the signal generator built into the LSI test system. It also has the advantage that it can be realized with fine time resolution. The principle of the TDC used is explained next. First, the SLR TDC is explained. Successive approximation register ADCs are explained before moving on to successive approximation register TDCs. The successive approximation register ADC determines digital output by approaching the output voltage from the DA converter by successive approximation using a binary search algorithm, so that it matches the analog input voltage in the sample and hold state. The binary search algorithm is a method of obtaining a digital output by repeatedly comparing a large and small analog signal with a clock signal. A successive approximation register TDC is one that uses this successive approximation principle to perform time differential measurement. This is the circuit configuration of the SLR TDC used in this project. One feature is the use of programmable delay element with a 9-bit 10 picosecond resolution as a delay element. We also created a program to control the delay value in the Arduino IDE. This SLR-TDC measures the time difference in the upper 9-bit. Next, binary TDC is explained. First of all, measure the time difference of the upper 9-bit and denote it is a TDC n. The range of n is 9-bit, so 0 to 511. The respective integral voltage are calculated from the minimum and maximum value of the bit. It also performs normalization using those values. Measure the integral output voltage when zeta is applied. Measure the code wide n-m to n+m. Since the integral voltage obtained follows a normal cumulative disruption function, the high resolution is achieved by determining the center value from its approximate curve. If the cumulative disruption is obtained with a code wide of 10, as in the present case, the resolution is 1/10. If the cumulative disruption is obtained with a code wide of 10, as in the present case, the resolution is 1/10. For a 9-bit programmed 10 picosecond resolution, a 12-bit 1 picosecond resolution can be obtained. Next, the linearity actual equipment measurement of binary TDC. We first evaluate the linearity of a binary TDC with zeta applied noise without a signal generator. Prior to the linearity evolution of the binary TDC, the linearity of the SLR TDC is evaluated. The distinctive feature in the circuit use up the program element and the Arduino IDE that control them. Other complex circuit configuration can be omitted in the interface conversion circuit. Here is an actual equipment measurement. In this case, the INL was calculated using the endpoint method, with 490 as the full scale because it overflowed by more than 500 code. After two measurements, INL was within plus minus 22 picosec. Here is a linearity evolution when theta is applied to the noise without using a signal generator. An approximate curve is obtained from the data using the Liebenberg-Marquardt method. The Liebenberg-Marquardt method is a method for computing least squares from the nonlinearity curve. The 1 picosec resolution can be obtained by finding the center value of the approximate curve. Next, we will discuss the Banyan TCC with data generated by the signal generator. Here is a circuit diagram. The difference from the previous section is that the signal generator for the generating zeta and the amount of zeta can be adjusted. Here is the actual equipment measurement. Use a variable delay to vary the delay value from 0 to 4 picosec. Also, turn the zeta adjustment knob to change the amount of zeta applied. In addition, data other than those near the center value are removed because they cause measurement accuracy to deteriorate. The measurement data use range from 0.2 to 0.8. Three measurement was taken at each delay value, and INL of the average of these measurements.
Dear presenter, you have 2 minutes left.
Evaluating three measurements without averaging. The linearity was plus minus 2 picosec. Averaged 3 times, we found a linearity of plus minus 1 picosec. Finally, a conclusion. The linearity was confirmed to be within plus minus 22 picosec in the SLR-TDC used in this study. By applying the appropriate zeta in the input clock, we took advantage of the fact that the measurement point follow a cumulative distribution function. We also found the INL of the Banyan TDC used in this study can be measured within 1 picosec. As a result, it was found that the TDC with 12-bit 1 picosec resolution is feasible when using a delay element with 9-bit 10 picosec resolution. Thank you for listening.
Thank you. I have some questions. You said that is a low cost. From a business point of view, someone would ask, what would be an approximation of that cost?
Sorry, the audio is hard to hear. It would be helpful if you could comment on your question.
Okay, and from the same perspective, what would be your return of investment?
Yes.
Other questions?
The participants can drop their questions in the chat box if they have any suggestions and questions. Yeah, so we'll move on to the next presentation. We have Estimi. Sorry if I pronounce it wrong. She would be presenting a paper on a proposed investment type recommender system based on the potential investors demographic. Ma'am, your screen is visible. You can start sharing your presentation now.
Okay. Okay. Hey there.
Please
Hello,
be a
everyone.
bit louder.
Yeah. Can you hear me?
Yes, I can hear you. Just be loud.
Okay. Hello. Okay. What about now? Now is better?
Yes, it's perfect.
Okay. Thank you. Hello, everyone. Thanks for being here today. And I'm going to talk about the proposed investment recommender system and it uses the demographic data of potential investors with ANFI. Our team, two persons are from Corvinus University of Budapest and one from big collaboration with University of Malaya, Malaysia. So this presentation aims to propose a system that can provide a personalized investment recommendation to potential investors based on their demographic information. We used ANFI's adaptive neurofuzzy inference system, which is artificial intelligence techniques that uses a fuzzy logic and neural network to make accurate predictions. Most recommender systems rely on accurate data and which can be hard to get from users. Advanced analysis is needed to process investor data effectively and reduce the risk of giving faulty recommendation. Moreover, most existing recommender systems don't take the data of potential investors and our proposed systems is address this limitation by using demographic data. Our objective was to develop a new investment recommender system using ANFIS that utilize demographic information to give personalized investment recommendations. And we collected data through an online questionnaire in 2019 with 1542 responses. Data we used we related to demographic and investment experiences. The demographic variable we used for segmentation include age and gender, education level, employment status, and monthly income. Investment type variables we used include bonds, stocks, bonds, real estate, and other investment products. And so how do I generate investment recommendation? We used historical investment data and the demographic data to develop a personalized investment type recommender system that makes accurate recommendations. We designed it in three phases: data gathering, data analysis, and decision. During the first phase of data gathering, primary data is accurate and stored from potential investors through a web-based questionnaire. Data is then transformed and prepared to enhance its accuracy. Next, the data is categorized, 5 related to demographic data and 1 related to investment. During the second phase, we use 2 functions. In first layer, machine learning techniques such as clustering are used for data processing and mining, specifically to cluster investment type experiences based on responses. The KMP used for clustering data in this project. Second layer of this phase involves ANFIS. Systems acts as consultant and studies the investors' behavior to make relevant and accurate investment recommendation. ANFIS consists of classification, implication rules, normalization, reclassification, integration, and aggregated output membership function layers. The third phase is the decision phase, where we present information to investors and receive their feedback. We can detect any probability errors and make corrections based on the data analysis phase. Application layer can be customized to the investor's needs and display recommendation based on investment company products and services. Our system framework overview demonstrates how incorporating user feedback expert knowledge can enhance our system's performance. We clustered investment types using hierarchical and k-means methods in KMP. In this slide, you can find a breakdown of investment type and their respective characteristics. Additionally, we have included examples of demographic groups that align with each class. Okay, so here is an example of different functions that you use in ANFIS layer. The first layer is just to pass on the input signals to the next layer. The fuzzy neurons in the second layer decide how dependent signal is on the neural fuzzy set. The third layer normalizes the firing strength of all neurons, which determine how valid the rules is for the input. The fourth layer calculates the weight of the rules results. Finally, the fifth layer, the output of all previous neurons is added together to get a numeric output, which is then falsified. On this slide, we illustrate the working of our system's membership functions, including their features and quantity concerning the system inputs. And this slide provides an overview of the system's information. As evidence, the systems has generated over 1,200 rules. So we provided several 3D graphs illustrating pairwise interface of inputs. These examples demonstrate how two demographic data inputs are related and which investment type cluster they belong to based on this relationship. To make sure our system is accurate, we calculated the root mean square error, RMSE, to assess the accuracy of the model's predictions. We want to show that our system is better than existing ones and can provide accurate investment recommendations based on demographic information. By coming fuzzy logic and neural network techniques, the model can understand complex relationship between input variables and investment preferences, making personalized recommendations. This could improve investment decision making for individual and organizational investors. Our system uses fuzzy neural inference and can handle incomplete and inaccurate data. Investment experts can add rules. New rules can be generated based on the feedback. We found that different clusters of investors have different investment needs. So our system can be continuously improved using user feedback. However, there are some limitations and opportunity for future research, of course. Our system uses complex algorithms to analyze demographic information and give personalized investment recommendations based on the user's profile. We use both linear and nonlinear parameters to make recommendations and consider a wide range of demographic factors like age, gender, education, job, and income. This gives a more accurate assessment of users' investment needs. And here you can see the references, and thanks a lot for listening, and I would be happy to take your question.
Thank you.
Welcome, you're welcome.
On a slide, there was a table with a column said number of pairs 0. Can you explain what's about that 0?
Which one? You please let me know which one.
This one. Number of checking data pairs 0.
Yeah, this is the rule. These rules. Please let me bring for you the system, and the system is here. Yeah, it is based on these sections. The system automatically generated the rules, and the table generated by the systems. And based on all of the generated rules and all of the parameters, all of the factors, we give output of the systems, and all of these results is output of the system. And there is no pair in this, in this system, there is no number of checking data pairs.
Okay, so from a key performance indicators point of view, this is a good thing, a bad thing?
Which indicators? Which one?
Let's say a company wants to have some key performance indicators, and they are just looking on the numbers, and they are asking, well, it's good that this number, it's low, it's bad.
Actually, we implemented 7 ANFIs based on different traits and factors. For example, personality traits, managerial traits, key decision factors, demographic, financial, and we combined all of the ANFIs, 7 ANFIs. And this one, demographic, is only one part of our system. In this case, combined systems very well, and we had experience with some company in Europe, and we tested the system too.
Okay, thank you. Other questions?
Yes, please.
If someone has other questions.
Yes, please. No question?
If there are no other questions, we can move to Professor Kudelik.
Yes.
Thank you
Thank
so
you.
much.
Thank you. So we have our next presenter, that is Robert, who would be presenting his paper on a short sketch of solved algorithms for feedback arc set. Are you here, Robert? Yeah. Robert, please share your screen.
Hello, hello, Robert Kulic here. Just a moment.
Yeah.
To share presentation. I guess you can hear me and you can see the presentation.
Yes,
Yes, yes.
Thank you for the confirmation. So, what is this all about? Feedback arc set was presented by Karp actually a long time ago in his seminal paper as NP complete, as well as for satisfiability, which is the root of that tree, and for other problems as well. Feedback arc set was proved to be NP complete from the problem known as node cover. And it is fascinating to see that this problem has many applications. I have stated here just some: search engine ranking, cell apoptosis, group ranking, deadlock resolution, information system, subsystems development order, etc. And this is something to think about for the audience and perhaps even for the chairs. Perhaps we can talk about it after presentation. Why is this so? Why does this particular problem, feedback arc set, has so many applications? If that is the case, and it is, then it will be a good thing to have quality algorithms for it, because this problem is not just important theoretically, but it is also important practically. And if we do not have quality algorithms for this problem, then we cannot solve real-world issues. We have problems for which we don't have, well, at least good solutions. When we speak about algorithms, of course, we speak about efficiency, which is most of the time and memory. It can also be convergence, and we can speak about perhaps about some other things as well. So, if we have an algorithm that outputs quality solutions but runs slowly, that is clearly not good. If we have an algorithm that outputs quality solutions and runs efficiently, that is in polynomial time, and uses a lot of memory, well, in today's world, this will probably not be an issue. It would be, for example, 30 or 40 years ago. Today, it is not. And for example, if we speak about convergence, if we have an algorithm that runs fast, that outputs quality solutions, but convergence is rather slow, this will probably as well be useless. And now we come to the methods to solve this problem. If you would do the search in Google, for example, for this problem, you would find that the methods to solve this problem actually span the breadth and depth of techniques, algorithms, and methods in computing. And the reason is the problem is quite old, and it has its beginnings very close to the dawn of computing. what the problem actually is. It is actually quite easily stated. You have directed graph G with vertices and arcs, and you are asking if there is a positive integer k which is equal or less to the number of arcs. The question then is there a subset of those arcs where the number of arcs in that set is smaller than this number, where that subset consists of at least one arc from every directed cycle in G. Why? Because if we remove all those arcs in this subset, that means that we have a directed graph which is acyclic. And this is actually what we want. This is what we need. So, aside from being NP complete, it is also NP hard and APX hard. Everything is not that grim because it can be efficiently solved on undirected graphs and in reducible flow graphs. And the dual of the problem is maximum acyclic subgraph, which is basically searching for a subgraph with nodes and arcs, which is maximum in terms of being acyclic. If you would search the literature for this problem, you would find, if you are very meticulous, over 200 papers, and that is excluding monographs, web sources, encyclopedias, and so on. Which means that it would be a good thing if we had one place where we would have, so to speak, a few good algorithms, which would be fast, which would output good solutions, where the information would be presented with brevity without the clutter. And that's why this paper was written. And one of the algorithms in the paper, because we don't have time for all, one of the algorithm is this. Its complexity is linear in terms of number of arcs, which is excellent because this means that it is quite fast and it can work phenomenally on networks that have millions or billions of arcs or nodes. So the algorithm, the main idea of the algorithm is this. First, you look in the graph for sources, nodes that are sources, and nodes that are sinks. And then you take sources into one group and you take sinks into the other, because clearly you want to have sinks on the right of the order and you want to have sources on the left of the order. And then when that is completed, you calculate for every node in the graph the difference between out degree and the in degree. And then you take maximum. And again, depending if you have a source or a sink, you would put it in one of the categories which you mentioned. You would either append it to sources or you would prepend it to the sinks. For example, in this situation, on this image, this situation with maximum difference between degrees, we would have for the node 4, which means that if that node is removed together with all the arcs, nodes 7, 5, and 6 will have an increase in the calculation, while the node 3 will have a decrease. Since we have removed arc 3, 4, node 3 is now clearly a sink, so it needs to be removed. Then node 2 would be a sink, and so on. In the end, we would be in a situation where we would have an empty directed graph. And at that time, computation is complete. And algorithm now needs to output the solution, which of course is sources, sequence of sources, and to that you need to append sequence of the nodes that are at the end, the sinks. And you have your sequence, and in this case, there is only one arc here that would be in this feedback arc set, and that would be the arc 3-4. Contributions of the paper are these. Firstly, we have presented here a short review and an outlook on this problem, which is clearly important considering the amount of literature that exists. We have also presented a few algorithms that span the breadth of areas and are good for a large number of purposes, are fast, and output quality solutions, which is also important. Why? Well, because if you need it for practical application, it is clearly quite inconvenient and a problem if you need to first go through at least 200 papers. And if you can find just one paper and find there fundamental information and an algorithm that is either perfectly suited.
Dear presenter, you have 2 minutes left.
Thank you. That is either perfectly suited or is good enough. This is obviously an excellent news. Secondly, if you are doing research, obviously you have perhaps and probably more time, but it will give you a head start on the research, and it will point you in the right direction. Why? Because the paper cites other important papers and monographs. You won't need to look it up and find it yourself, and you will be in quite a good shape. And with this, I would conclude this talk and would yield my speakership back to the moderator.
Okay, thank you. I have a question. You said that the algorithm can handle millions of arcs. So could you give some real-world applications where feedback arc set can be used and where other algorithms would fail?
Let's take this. There was a research that was done. It was called feedback arc set at web scale. If you have, for example, a social network and you want to find some sort of a priority and a feedback loop or a self-reference, clearly even an algorithm that is polynomial is not good enough for the purpose. And as you have seen, this algorithm runs in linear time. So you either need to have an algorithm that is linear or logarithmic. There is no logarithmic algorithm for this problem. That would be quite optimistic. But there are some that are linear, and that is greedy fuss from well-renowned expert in this area, Peter Eads. There is also Berger fuss and some others, but there are not many. If we are speaking about some other real-world applications, for example, we can use this. What if you would like to find out what would be the base priority for developing subsystems of information system? How would you do it? So you have subsystems and you have data classes, but what now? You could calculate affinity analysis, but whether that would be a good thing is debatable. On the other hand, you could use an algorithm for feedback arc set, and you could get a priority that goes from the system itself, which could be argued is a strong case to do it this way. I'm finished.
Okay, thank you. It was really nice. Does someone else have questions?
Hello.
Hello?
Hello, Mr. Robert. Yeah, so I would like to ask a question. So you have worked with the greedy approach, right?
Right.
Greedy algorithm.
Yes.
Yeah. So have you applied any heuristic function in this algorithm part?
I have worked on a heuristic algorithm for the feedback arc set, and it can easily be found online. The approach is actually quite similar to the algorithm that we saw now. But I have also worked on the Monte Carlo randomized algorithm for this problem, which is much more interesting. Why? Because this is a problem that is quite hard to solve, and it has been proven that is also APX hard, which means that it cannot be solved for every approximation factor. But that isn't the case in terms of probability. So I have developed an algorithm that can solve feedback arc set in polynomial time with arbitrary probability, which is phenomenal because now we can not only get very close to optimal solution, but we also know how good that solution is. Of course, we can never be we can go even to 99.999%, but we can never know with a 100% whether that is an optimal solution. Although empirical experiments results have shown that the algorithm either finds an optimal solution, or it finds a solution that is within 3% from optimum. That would be my answer. I don't know if you are satisfied with it.
You are on mute. You are on mute.
Testing. Am I audible?
So sorry, so sorry. Yeah, you can share your screen, please.
Hello?
Yes, Nicholas, can you hear me?
Okay, I can hear you now. You were buffering a bit for me, sorry.
Yeah. Now you can share your screen.
Yes, just give me 1 second here. Share should be this, and then let me know if you can see it.
I can see it, yeah.
And I'll just start, I guess. All right. So my name is Nicholas Follett, and I come from the University of New Brunswick, Fredericton campus for the Faculty of Computer Science. And our paper is titled, I Am Bot, the Fish Finder, Detecting Malware that Targets Online Gaming Platform. My other authors are Yazir Baziri and Brijinder Kaur, and we'll just get ahead. So a quick overview, we're going to look at the introduction and motivation, and then talk about the design, implementation, and testing. And depending on time, there will be a demo, hypothetically, a very small one that's fast. But if not, there's a little workaround with some pictures I have I can show, and then talk about the future work and conclusion. So an introduction here. So from a background perspective, the video game industry in 2021 was found to have a $175.8 billion growth in that year. And the value of the value of an account or a user is not just based on like their credit card value or what they're associated with, like their connection with their PayPal or whatever. There actually is a value behind the account itself. As you see here, this is actually my personal account on Steam, and it has a value of approximately $1,000 to $4,000 Canadian, based on all the items I own, like the different video games I actually own on the account, or the different cosmetics and stuff I have associated with this particular account. So people aren't just stealing it for like their use of the person's credit card or their PayPal information. They're also stealing it to get access to the items within their account. So I guess the problem here is that ever since the COVID-19 pandemic, there's been an increase in web-based gaming attacks. And as I stated, once an account is compromised, malicious actors tend to try to get these accounts for reuse or selling it or stealing the items off the account. And they traditionally tend to change the password once they steal it and try to sell it to other users. So the motivation really in this area is the lack of research done in this area. And then another critical factor is that in general, most people of the gamer age group is from the age groups of under 18 and over 55%. Over 55 make up 36% of total gamers. And these groups generally are the more susceptible to these attacks, as children tend to want to get stuff for free without having to do anything. And if the link says, oh, click this link and you get a free account, well, they're going to go after these attacks. And that's why they're more viewed as susceptible to these phishing attacks. So from a design, implementation, and testing perspective, we utilize the data set created by Hanhausen, and it has 11,430 different website URLs, and they extracted 87 different types of features from stuff like the link for the URL, the number of hyphens in the URL, and different stuff like if it's a subdomain versus a full domain, or if they use a shortening service to actually change the data, like to change the URL length. And it gets all those, we worked with those features and utilize these some different feature selection methods as seen here. And after conducting the feature extraction, we noted that in all the cases, the different the three things came up in all different cases, which were the number 21, which was the number of W's, 51 phishing hints, and 86 the Google index were common across all of them and during the feature selection attempts. From a machine learning model, we opted to use 5 different approaches, and utilizing Python, SCK-kit learn, and we utilized the 30-70 split for testing and training, and ran cross-fold 10, validate tenfold in order to measure the accuracy and performance. And the study produced a different of approximately 40 different machine, like as you can see here, there's, yeah. And we compared their F-score, we call precision and accuracy, and we found that of the feature selection and the algorithm approaches, we found that this S3 with random forest, S5 with extra trees, S6 with random forest, and S9 with random forest performed the best overall out of the 4. And because of the way we were doing this, we decided to use all 4 in order to make an approximation for the end user, as most of the end users are not technically savvy for this. So another thing is we kind of jumped the gun a bit, and we didn't really talk about what is Discord. So Discord is kind of the area that we're looking at for these attacks. And it's kind of a gaming communication platform. And it's not just for gamers, but it also can be for other communities. But it can be kind of viewed as like a Microsoft Teams. It's free. You can have as many servers as you want. You can add friends and have communities and talk with people. So here's kind of the application flow as we have right now. So the Discord server sends a URL to the Discord bot controller. The bot controller then passes the URL to its feature extraction, to extract all the features that we selected from our 4 different feature selection methods, and returns those features to the bot controller, which then passes them as parameters to the 4 machine learning models, and then gets the results back and then returns it to the Discord server. So from an end user perspective, the bot will return a message, and return a little emoticon showing the status of the post or the URL. So as you can see here, for legitimate, we have green show up, and that it found that Facebook was legitimate. However, for Stack Overflow, one of the 4 algorithms detected, or models kind of detected that it was determined that it thinks it was phishing. And then there's kind of another point here where in actuality, there was 3 tests done. The 3rd test was completely detected as phishing, and so the post is automatically removed, but you're able to check it in the logs on the server, as it will show the actual status between each one and show what it found. So I think we have enough time for the demo here, so I'm just going to play it here for a second and just talk over it. It was pre-recorded for another purpose, but I can just speak to it here if it will play. So right here, it might be a little blurry. It's basically the typing in the address to facebook.com. And then when it does that, it gets a little notification, which is like a stopwatch that shows that it's still running. So it's running. And then once the logs show up, it comes here to these logs and posts the result of the phishing or the URL, and it shows that it's green, which means that it detected, and all 4 determined that it believed it was not a phishing URL. So, and then in order to prove that, in order to make it so that some malicious user can't just go add the emoticon, it actually shows a list of the users who used it. You can make sure that the bot itself posted the emoticon. And then here we're going to fish tank to get a known registered phishing account or phishing URL, passing it into the bot itself. So as you can see, the stopwatch there indicates that it's currently processing it on the back end. And then as you see, the URL was removed. And you can see the report generates there, showing that all 4 determined it was a phishing attack or a phishing URL. So we're just going to talk about the future work and kind of get into the conclusion here. So from a future work perspective, there's kind of 3 key areas behind this work. So one is the current developed program can only process a single message at a time, with messages queued for sequential processing. However, larger Discord servers could run into latency issues, where if there's a high volume and number of messages generated in a short period of time. So one of the things to do is possibly implement some more parallel processing to handle this request, or look at a different way to use the Discord API in order to kind of streamline the process. And then another thing is a study could be conducted to basically kind of increase the size of the data set. So right now, the 11,400 different URLs is a pretty good size, small size that set. But I feel that we'd have better accuracy and precision if the data set was larger, and we wouldn't have to rely on the 4 sub algorithms, and we might be able to allow people to choose which one they think they like out of like a list, and they can use that on their own on the end server side. And another and that kind of ties into the algorithm simplification, which is the fact that we have 4 right now. We want to kind of make it so that they only really need to use 1 at the end to show the results. And that can be something we look at, and they're kind of tied together in this future work. So from a closing remarks perspective, we created the creation of a machine learning solution for credential phishing on the Discord platform. And the Discord bot itself, Fish Finder, can be found available at the Skit repo below, available for people to actually contribute to or download and implement on their own Discord servers themselves. And that's kind of it for the presentation.
Okay, thank you. I have some questions. Which machine learning techniques were used in this study, and which technique achieved the highest accuracy, precision, recall, and F1 score?
So from a machine learning perspective, we utilize decision trees, random forest, ADA boosting, extra trees, and gradient boosting. And overall, I would have to say, if memory serves, I believe it was the second, it was random forest with our second set of I can't think of the word right now. Selected features. Am I not audible?
We can hear you now.
Did you not hear what I just said?
You pause for a few seconds.
Okay, I guess there must have been an issue on my end. I apologize. I was saying that if I remember correctly, it's random forest using the second subset of features we use. So F2, the random forest generally perform the best.
No, okay.
Thank you. We'll move further. Have our next presenter. Sebastian, who would be presenting his paper on mHealth system for detecting COVID-19 in chest X-rays using deep learning and data security approaches. You can share your screen.
Okay, I'm ready. Can you see my presentation?
Yes.
First of all, my apologize because my camera have some problems. But I'm Sebastián Quevedo, but my partners are Johnny Delgado, Luis Clavijo, Carlos Soria, and Juan Carlos Ortega. And all are from the Catholic University of Cuenca in Ecuador. Our works is about mHealth system for detecting COVID-19 in chest X-rays using deep learning and data security approach. So what the contents we take in this presentation is introduction, problems, the objectives, the methodology using, the results, and the conclusions. So first of all, automating pathology detection in chest radiographies, which could match the effectiveness of radiologists, can benefit large-scale screening and health initiatives in all the world, because more than 4 billion people of the planet population don't have sufficient access to radiology service. So maybe 2 billion procedures are carried out annually, converting them into an essential tool for diagnostic and treatment many types of disease. Automating the detection of COVID-19 disease in X-rays, which will be a less practice radiologists, could benefit large-scale screening and health initiatives. And right now, advances made in deep learning in the last decade have enabled algorithms such as deep neural networks to match the performance of medical professionals. But what the problem is? The problem is that COVID-19 detection has general significant interest in the deep learning research community, and several solutions have been proposed. A lot of models you can see and the state of, but the problem is that only a few studies have been able to bring these models to a production information service. And these few studies, only a few systems with these characteristics comply with information and data information security parameters. So in our proposal, first of all, we propose this model.
I think we lost connection.
We lost his connectivity. He left. We'll wait for 2-3 minutes. If he's back, we'll take his presentation as he was the last one. The other one is absent, so we'll wait for him to join again.
I'm sorry for that. I have problems with my computer. I don't know why.
No problem. You can start from where you had left. Just pick, please.
Okay, thank you. So in our approach, we use chest race image put in a convolutional neural network and gradients of where the COVID-19 is. So for training this model, we use two data sets, BMMCB and Kaggle COVID datasets, and we training and testing the process of all our architecture and build that with Python TensorFlow. All the image we resize to 224 by 224 pixels for the input. Data augmentation techniques like random width sweep, weights, random rotation, and brightness. But not all the data augmentations was implemented because, for example, you can use the flipping approach in data augmentations because if you image the heart is in the other side of the chest. So this is other disease. So we implemented a fine-tuning process on the DesNet 121 architecture by implementing transfer learning with the pre-trained weights of the ImageNet dataset, and we modified only the last layer of the model to do the binary classification with a same activation that encodes the probability that the analysis image. So this is our approach. You can see in the left side, you can see the front end in red colors. You can see in green colors or backend, and in blue colors, you can see the prediction model. So in the front end, we create a welcome web interface that all the users can register first with fields as ID, name, surname, and so on. After activation, it's possible to enter security using OAuth 2.0 authorization framework for protecting the data, and the login interface requires email and password to validate the backend and authorization. You can see in this slide, we implemented the backend, and the backend is composed by three types of things. First of all, the OAuth 2 approach, the backend, and the prediction model. So an application based on microservice was implemented, which is created using a domain model software construction paradigm. The persist layer implementing security system based on OAuth 2 security framework was implemented to access the exposed API, and for protect all this is we implement OAuth 2.0, and finally the prediction of the model implement using GradCam gradient weights for see what the model see. So the tools we use for this approach, we use Angular and Ionic for the front end. From the back end, we use Springbot, Postgres, and from the prediction model, we use Flask, DenseNet, implemented with Keras and using Python. So what the results for the model? The model had a really good precision sensitive and specificity and ROC. You can see in this image all the process for training the model. You can see we only have maybe 20 epochs because we use transfer learning, so our model really well with the data. So we have a really good accuracy for prediction the disease in the checks rates. So in this layer, you can see our system. You can see the front-end approach. You can see the COVID detect, the login email, and for example here, the user can choose and push this button predict, and the user can upload an image, a DCOM image, and the model interpret this image and say, okay, your image have COVID or not have COVID. In case the image have COVID, you can see the gradients on where the model is, where is the COVID-19 is located. So we tested our approach using a OWASP approach for trying to see where the vulnerabilities are. Using the OWASP tool and making the necessary configuration so that I can act with a main in the middle attack techniques, and audit is carried out and the COVID-19 prediction information system attacking the target IP where the penetration testing resides virtually. The attack on our information system has been successfully carried out. So what are our conclusions? In this context, we have performed prediction experiments for COVID-19 disease using an X-ray image. The proposed model provides 98% accuracy in detecting COVID-19 disease. The implementation of the security at access and authorization level was carried out using the OAuth 2 protocol to service using a token generated from encrypted data. So finally, the information system was audited with the OWASP methodology with encouraging results since it present 4 risk alerts of types mediums and 3 of allowed type, which place the information system safe after making the correction in the programming that are presented in the audit report. So this is our presentation. Maybe somebody has some questions.
Yes, thank you. How large was your training data set for the predictive model?
How many images?
How big was your data set for the predictive model?
In total is like 10 gigabytes.
Okay, I mean more in instances of photos, not necessarily gigabytes.
How many? Like 26,000 and 123 images.
Okay, and how does your proposed COVID-19 prediction model compare to other models?
Oh, okay. Actually, the state of the art, we can see better models for prediction, inclusive other types of disease in checks X-ray. But the principal objective here is to put this model in productions and implement a secure data approach. So easily can change our model and put other better. So I don't know if you satisfied with my answer.
Yes, I have another question. What are some potential limitations or challenges of using deep learning for medical image analysis and data security in healthcare settings?
So the principal challenge is because you are using medical information. So for ethical reason, you can use this information for free. You need to be very carefully with this information. So you can, it's quite difficult to find this information for training the models. So I think this is the most difficult approach to do, I think.
Okay, I understand. And from the security point of view, what are some benefits of using the OAuth to access delegation?
Because this is one of the standards for data security. So when the data is traveling in the internet, all the data is encrypted with a tokenizer. So when using this type of system, you use a data really important, and you need to try to protect the information. So when you use this OAuth approach, you can protect the information when the information is traveling for the network. But you can implement other approach too.
Okay, and do you have also two-factor authentication?
I'm sorry?
You also implemented the two-factor authentication?
Yeah, we have a second factor of authentication because when some medics can use our approach, we send an email to these medics, and they need to guarantee with a link that they use correct this approach. So implementing to an administration platform for activate the users. The activation for users is not automatically. We use a special formula for activate some users.
Okay, I understand. Nice. I don't have further questions.
All right, thank you. This is the end of this session. I sincerely thank our authors for their excellent presentation and contribution in this session, and all the participants to be a part of this international conference. I hope this session was informative enough. We, on behalf of the entire team, thank you for the support during this 8th version and the previous 7 versions. We would love to see you in the 9th version as well. All the presenters would be getting their certificates through email within 2 working days, and the publication would be live within 6 months. The papers have been already forwarded to the Springer board. Kindly cooperate with the team. I also thank our session chairs for chairing the session. This is a token of appreciation from our side. Thank you so much, sir, Kirit sir, and Alan. Thank you so much. Thank you so much for sharing the session. And,
Thank you.
Thank you for all.
Thank you so much. I request the participants to turn on the cameras for a quick snapshot, please.
I'm sorry because my camera is out.
No problem, no problem. Thank you so much. Stay safe, take care. Bye-bye. Thank you.
Thank you. Bye.
Bye.
Thank you.
Bye. Bye. Bye.